Hey everybody, today I'm going to talk about example 6 in the node testing code for Zulip. My audience here is people that are writing node tests for the Zulip JavaScript client. And example 6 is kind of an interesting example of testing Zulip insofar as the example doesn't actually exercise any actual Zulip code, but instead it demonstrates the technique of making a stub, separating out all the specific details of how this becomes useful for testing Zulip code itself. And the reason that I constructed the example this way is that I just wanted to remove some complications relating to the actual Zulip code and just demonstrate the core concept of making a stub object. And I use the classic programming example of writing like a basic bank application where you're making deposits and into a bank account. And so we simulate this idea that we have this application where we can notify the server of a deposit. But in a unit testing context, it's difficult to interact with the server. It just creates a lot of complications for the test. You have to fire up a server and so on and so forth. And what we want to test from the client perspective is not that this actual round trip of notifying the server of the deposit works, but just that we are calling it with the correct deposit amount. So we say here in the comment that we're going to simulate the difficulty by throwing an error. And likewise, if you have a banking application, after somebody makes a deposit into the account, the application might pop up some fancy confirmation screen, and this has the exact same difficulty for unit testing that server interactions have, that it's just difficult to test UI interactions. And again here, what we want to test is not that the actual full process of popping up the fancy confirmation screen works. That would be something that you would test in Puppeteer, and it would be useful to test in Puppeteer, and it's entirely possible to test in Puppeteer. But from a node testing perspective, you're doing more unit testing, and you just want to verify that we're making a call to the function pop-up fancy confirmation screen with the correct deposit amount and the correct label, but we are not interested in the actual behavior of that function. So we're not even going to call the actual function, and that'll become clear in a little bit. But let's get down to the actual code that we're going to put under test. So we're going to assume that we start with a balance of 40 units, which, you know, if you're an American, you would think of them as American dollars. So and I am an American, so I'm going to call them American dollars. So we start off with $40. And the deposit paycheck function receives a paycheck amount. So, I mean, the notion that we're simulating here is literally somebody getting a paycheck from doing their job, and they go to the bank and they deposit it. And we want to say that the balance gets incremented by that paycheck amount. And then the app object here, which is sort of implicit, needs to notify the server of the deposit, and it needs to pop up this fancy confirmation screen with the paycheck amount with the label paycheck. So the methodology that we use in the Zulip node test, and this will apply to actual Zulip code, but hopefully this demonstration outside of Zulip code is still instructional, is that we're going to override the app objects. We're going to override two functions of the app object module with stubs that essentially do nothing. So we're going to override notify server of deposit with a function that does nothing. And then we're going to override the pop-up fancy confirmation screen with a function that does nothing. And we're going to deposit the paycheck. And note that even though we have a function that is difficult to unit test because of the server interaction and because of the UI interaction, we can still establish the fact that the function is doing the correct thing on a data level. That I started off with a balance of $40, and now I have a balance of $50. And one of the reasons I like to do these videos is that I kind of want to make a meta point. When you have a function like this in your application, and this certainly applies to Zulip code in certain places, it's entirely possible that you've structured your code in the wrong way. So whenever you are seeing code that requires you to make these stubs, it's entirely possible that the code is not structured at least not in the easiest way for testing. And it's a general rule of thumb that if code's not structured in an ideal way to test, that's probably a good sign that it's not structured in an ideal way to maintain in general. So there should probably be a deposit paycheck method here that's like on a bank object and not like so closely coupled to the app. I mean, eventually you are going to need code that is going to notify the server deposit. You are going to need code that pops up a fancy confirmation screen. And it's not like you can totally eliminate that interaction, but you do want to isolate the data properties as well as you can. But this example is not so much about telling you how to structure your code. It's telling you about how to test existing code. So after this first little chunk of code here, where I override the app stubs to basically point to empty functions and only make an assertion that the balance increased by $10 from 40 to 50, I say that we can do a little better here, as I say in the comment right here. And I say even though the two side effect of functions are awkward here, we can at least make sure they are invoked correctly. And that's something that I did say earlier in the video, is that we don't want to test the entire interaction with the server or the entire interaction with the user interface, but we do want to at least make sure that we are invoking those functions with the correct values. So what we do here is we use this make stub helper, and this make stub helper, pardon me for a second, comes directly from the testing library for Zulip, the node testing library for Zulip. So we require the lib stub library, and from that we pull in the make stub import. And when you make a stub, what you can do is you can override a function on app with a function from a stub object. And what happens when you do that is that every time that stub function object gets called, this notify stub object records the arguments that it was called with. So down here, we can make an assertion using deep equal that the arguments, that the notify stub arguments are amount 25, and that when we call the pop-up stub, and again, the pop-up stub is basically a stand-in for the call to pop-up fancy confirmation screen, then we make assertions about its argument calls. And there's a little bit of mechanics here that you need to understand. So when we call get args, we tell essentially the stubbing library, essentially make the make stub underlying code what the arguments to the function are, and then it kind of collects those into a dictionary. And I think the best way to understand this code is just to think about it in a pattern matching perspective. I think you can see here that like when we're making assertions about the pop-up stub, we know that that's pop-up stub is basically acting as a stand-in for pop-up fancy confirmation screen. And if you go up to the quote-unquote actual pop-up fancy confirmations screen, things are a little contrived here for the purpose of tests, but if you go up to that, then you can see that the pop-up fancy confirmation screen is receiving two arguments that are an amount and a label. And actually down here, you can see that we don't necessarily require you to even use the same words, although I think if I had written this again, I would have chosen to use the exact argument names. And I think in general, it's good with any non-trivial set of arguments to kind of pass them in as a like a JavaScript object, but that's a little out of the scope of what I want to explain here. But the main point here is that we use two different strategies to test this simple method here. The deposit paycheck, we know that the most essential part of the deposit paycheck function is that, of course, that it keeps your balance correct. Like if you deposited $10 into your account starting with a balance of 40, you would be pretty upset if it were not at least excuse me, $50. But the other important part of that function is you want to make sure that the server is in fact notified of the deposit, and you do want to make sure that you pop up this confirmation screen, and you can test that with stubbing pretty effectively, not on a totally deep level, but deep enough to at least prove that the interaction of the objects here is correct. And I think that does help make the function less buggy and more stable. And I think it's a valuable thing to do in node testing. All right, thank you for listening.